Yeah, good afternoon. Thank you. I'd like to firstly thank PyCon Estonia for inviting me to share what I know here, what I know, what I've experienced, all my skills, something that I can share with people who attended here. And yeah, again, so let me introduce myself really quick. Because I only have 30 minutes, right? Devlin Duldulao, so I'm based in Oslo, Norway. Been working there for 3 years, but I came originally from Philippines doing my software development there for 8 years. And yeah, so doing a lot of development, full stack, and writing Terraform scripts, for infrastructures, building. So today on this topic, I will share to you about retry policy, the importance of retry policy, circuit breaker pattern, and a little bit about microservices for anyone who've thinking how microservices works, and especially how would you expose your APIs to the outside world, and how would they communicate. So this is a little bit of everything, overview. Okay, so yeah, agenda, exposing microservices, that's one. Retry policy, which is I already mentioned. And then we'll go with the demo after these three topics that we need to know, right? Okay, so how can retry policy help us improve the end user experience? Well, here's an application, and we have our user here, and this application isn't using a retry policy, so no retry policy first. So we start off here with our user making some requests using the application. The application here needs to go off to some external service, right? And then this could be a temporary problem in the remote server, that the network connectivity dropping out for just a moment. You know, in any these cases, we're going to have result in some error conditions, right, in the application, and then we're going to tell the user about this error condition. And we perhaps might say something like, please try again later. So we need also to know why web service requests fail, right? Your web service request travels over combination of cross unreliable communications channels, traversing more computers, causing even more complex and unreliable software to execute. Now, those are, what we may encounter called network blip. Network could blip anytime, and for example, infrastructure upgrade, faulty network connection, what else? Null reference on someone else's code, server unavailable, a bad deployment can happen, right? And more. Yeah, there are other reasons that error could happen, but the point is we cannot control how a downstream dependency could behave. So yeah, but we can control how we can deal with it, and that's where retry policy comes in. A retry policy can retry a failed request with just a few lines of code, but that's the only start of what retry policy can do. Now back to the failing request. So rather than the user having to go and click the button repeatedly until it eventually succeeds, we can get the retry policy do this for us, right? So again, rather than immediately returning an error message to the user, the retry policy will automatically go and retry the request again, and retry policy can be, by the way, can be configured to go and retry third time. And this time, the operation succeeds and we can return the result to the user. this all happens transparently within the application. So the user this time has not received an error message, which is good. Good user experience. And they also haven't had to go and manually click, again, the button multiple times and get pissed off. So, yeah, that example is for front-end apps. But we're gonna, we're gonna we're gonna learn something about Retry Policy in microservices applications, especially this one, the downstream microservice failure, right? Dependency failure. So, little overview of microservices. Are usually built to be called by application or used by external consumers, and the way it's done will determine how the software should be developed and how it can be can evolve. So there are 3 ways to expose microservices. Directly, we have facades and API gateway. Let's go to direct access first, but I wouldn't recommend this. Don't use this. There are some pros and cons. Pros, no additional components, lazy approach, very straightforward. Backward compatibility is addressed in each microservice and a little less work. Cons, multiple entry points, extra complexity. There's no clear perimeter. Every microservice must be secured, and adding extra latency and complexity. This is not ideal. So we're going to skip this very fast, and let's move to the facade. The second option is to expose your microservices through specially developed facades, and there are 3 different ways how you can do this facade. First is the single universal facade. This is the first subtype, by the way, and only single facade that exposes the system's full functionality. So yeah, we can go to the pros. This method will allow you to protect your internal designs and make the evolution of the microservices a lot easier. That's one single entry point, simpler and better security, place to tailor and optimize external requests, right? And this is platform agnostic, by the way, will work anywhere. Feature-rich, multi-protocol, async notification, more, because you'll be the one who configure the facade and do the logic in facade. Cons, of course, there are some drawbacks that you need to do extra work to implement these microservices with facade. And if you need to introduce a new feature into your system, most likely it will affect your facade. So facades will be constantly be updated. Another variation of facade is the so-called BFF, or backend for front-end. Good use case, your company has mobile applications and a client application, and you want to separate the logic between the mobile apps, APIs, and what the front end, what the web app client is getting. So that's a good use case. This facade is built for specific consumer. Again, that for example the mobile, and then separate the web client. And usually an application is optimized for calls, like I said earlier. Similar approach to first one. You can protect your internal design and make future changes a lot easier, and you will have only single entry point, for specific application. So let's move to cons, drawbacks, extra work to implement. Right. So that's the only con that I can see here. This additional work. Third variation, multiple facade. Here it is. Same thing. You have now 2 facades, or multiple facade if you like. It's going to be consistent development and delivery practices. Again, platform agnostic, feature rich, multi-protocol if you want, and with extra optimization of application requests. Drawbacks, higher complexity, multiple entry points. So that's for the multiple facade or in facade in general. Now we can move now to the next or third one. How would you expose your microservices? Third one, API gateway. Simple as that. By using third-party technologies. And there are different options you can have here. One would be cloud-native AWS API gateway. That's one. Microsoft Azure API management, for this cloud-native. Simple free cloud agnostic, Kong, HQ, and Jinx Plus. You can do that. Or APG from Google. Actually, it's Google Cloud already bought it. To give you more like an overview of how this would look like in real world, so we can move to Microsoft Azure API management. It's going to be like this with a lot of helper tools, and you can set, you can declare whatever HTTP verbs you want to put there. What's good about this is you have this inbound or outbound policies that you can configure out of the box. You just have to click and then write some stuff easily, and then you have already this how you would expose your microservices out of the box. One thing that I would also add here is most of the time this kind of technology can automate this HTTP verbs declared here automatically if your API has Swagger definition, and then it will just consume that JSON from the Swagger, and boom, you have this there in your API management. So enough for this. Let's move to pros. Internal architecture is hidden, easy evolution, single entry point. But the most important thing here is this one, extra security. You don't have to deal with this anymore because it's part of the product of this third-party vendor or cloud that's gonna, that you'll be consuming and be using out of the box. With SDK API productization, website, automatically it will generate a website for you with documentation. So cons, because I'm not here to sell these kinds of services. So cons, extra technology to learn and maintain. There's a learning curve in doing this. Limited functionality, hard to support, complex parsing, especially if the product is fairly new or not yet, like fairly new, like 3 or 5 years, not yet stable or been working with extra features. So so these are how we would expose your microservices. Now, let's jump back to Retry Policy, and maybe we can connect this with our microservices. But of course, we forgot to define what is Retry Policy. So now here, Retry Policies are nothing but, you keep trying. So you make a request to another service or maybe an external API or service to get data. So that's Retry Policy. And the circuit breaker pattern, this is especially important when you're sending lots of concurrent requests. You can quickly run into big problems such as port exhaustion. If you're using HTTP client, that may seem like a DDoS attack because you don't have any protection for your other services. And what's going to happen is that, for example, the facade service is doing a lot of requests, right? And then users, it's like hundreds of users, keep doing this retry requests. So, of course, what's going to happen? Multiple it by 5 or 10, depending on how many extra requests you want to define in that application or service with retry policy. So what's going to happen if you don't have protection is it's like a DDoS attack in your own service or product. So circuit breaker is very important, and there are two things or three that you need to know here in circuit breaker pattern, and actually it's an electrical engineering terminology. Close means in circuit breaker, the wire all wire are connected. So meaning the electricity will just flow continuously without any problem. So that's one. And when you read something in circuit breaker, it's open, meaning a wire is not connected or loose, so no electricity will flow in the system. So that's open, meaning it's closed. So this is gonna protect your service from your own DDoS attack to yourself. You're preventing additional requests to your service. And I'm going to show it to you later how you're going to do that in Python. Half open is just opening it in few requests just to test the water if everything is okay. So everything's okay now, you can just come in and send your request. So that's the idea of half open. You're just testing a few requests just to see if everything there is okay now. For example, there's an outage in AWS or in Microsoft Azure, and just your application just testing if outage has already been fixed. But most of the time it takes hours, to be honest. So, okay, so there are two ways on how you would deal with retry policy. One would be infrastructure-based resiliency. Infrastructure, an example would be a service mesh, an Istio. So you have this, for example, here with Istio, you can define retry policy with a traffic rule, offloading this logic to your services, sidecar proxies, and the API management that I showed you earlier from Microsoft. So that's one. And here's gonna be, you click something, there's an inbound, there's an XML format there that you have to configure, put the retry condition, the count, the interval, and whatever you want to add in these options. And there you go, you have this retry policy already. Very simple. And, which is the one that I'll be demoing later, is a code-based resiliency, right? So to implement code-based resiliency, you can write a logic or use a third-party library for resilience and transient failure handling. So examples would be in Python, would be the retrying and Pyfailsafe. And where you're going to put this, there's an example. Again, you have this facade here that's sending requests, right? So retry policy code base should be here. API gateway, of course, you have that in the built-in facade. Another facade also, and some other services, right? Doesn't have to be facade, but if that service sends requests to another service or talks to another service, that's your queue there that you need to implement it. And now for demo, still have 10 minutes. Yeah. So, demo time. So, I have two services here. I name it facade, this one, but I'm not gonna talk about anything here yet. Just go with this to-do API, so it's like this fast API with this router, this very simple router with, just it requires an ID, and then I have a, so thank you for telling me. Yes, the mirror here. Of course, display settings. There you go. Sorry about that, that was 10 seconds. Time for. Anyways, again, I have this fast API application. Sorry about that. So this is the other service, and I have a facade with using Django. So here, I have a router, very simple, requiring an ID, and I have a randomizer here, run range. And the idea here is, if random number is greater than the to-do ID, or the ID that I'm going to pass in the URL parameter, I'm just going to log to-do service return 500 error, and then raise an HTTP exception. Okay, so meaning it's going to throw an exception, there's an error in the service, else I'm just going to return the ID or the URL parameter that I'll be passing. So this is just a 50-50 chance of getting an error message and getting a 200 response. By the way, I forgot to mention that it's also important to just use this retry policy in certain status code. You know, of course, if you're talking about 401, you know, you don't retry 401 if that's really not the password that the user is entering, right? Use only in specific status code, especially 500, 503, right? But bad requests, because of an aligned schema of your object, you know, you don't retry policy that. Okay, so yeah, this is a big thing. Okay, so yeah, 50-50. Maybe we can try this, but not 50. So 99. So greater chance of getting response, right? And if we set it to, say, 3, of course, most likely we'll get the to-do service down. So this is the service, to-do service that I created, and then let's move on to the facade. Let's remove this retry policy first. So here, I have an endpoint here that requires, again, a URL parameter, right? And it's just basically sending it, just a relay. This is just a relay sending to the service. Nothing special, as you can see here. API to-dos going to the to-do API. If response status is 500, just gonna log it. Facade API received a failure, raise connection error, can connect after 10 retries. Else, receive success, right? And I'm just going to receive what I just received from the to-do service. Okay, maybe we can try this. This is without retry policy. As you can see, I commented it out. $99, yeah. And then 1, it's gonna throw an error, right? No matter what you do. Now let's put back let's put this one, the retry policy. Save it. Let's try it again. Okay, it's okay. So let's maybe do 40 or 30. Then look at this one. Look at that. It's still it keeps on spinning because you will see here it's already there. How many failure? 1, 2, 3, 4, 5, 6, And then the seventh, success, right? And then what we can do here is, let's say another 20. So you can see from the log here, that's being logged. So 20 meaning it's gonna be lower chance of getting successful. So that's the idea behind that. No clicking, no clicking. It's just the facade does the retry request and gets the 200 okay. Isn't that okay? Like applause? Sorry. so that's really cool. That's really nifty, right? And yeah, let me show you that annotation there. Oh, damn. So what's the definition here? Stop max temp, 10, right? Delay. You have this delay. 3,000 milliseconds, wait fix, 3,000 milliseconds. So these are some configuration that you can use on top of this retry library, retrying. And then we can now do the circuit breaker. So otherwise, we'll be DDoSing ourselves. Here, if we don't have this, imagine all the users, for example, all of you sending requests to my server without protection, and you're just keep on sending these 10 requests to my service. So in order to protect it, circuit breaker here, save. Now let me show you how we can use that. Maybe we can use it, okay, here. 1. So we have to wait, and that definition of my circuit breaker there, threshold, how many errors? So let's imagine 2 of you retrying, doing this retry, and then receive an error for 500. That's the time I'm going to close my controller, and the controller, this one, won't even send a request to the to-do API. So that's how circuit breaker would work. It's not just sending you a request or a response, an error response. What's going to happen is, from here, you're already cut. You're already blocked. If you're the third person who'll be receiving that error. So this cycle is 1. So can connect after 10 retries. We're gonna do it again. This URL parameter 1. So chances are it's gonna trigger the circuit breaker. So 10 times. We can't see it here. All the way. You just have to wait for another one. Because our threshold is 2. So there you go. Now, for the third time, it says circuit is open. And then no matter how many users will send requests, it's just gonna, that annotation there, which is gonna block your request, and then it's not gonna send anymore. It will just stop sending to the external service, the other service. So that's the circuit breaker. And to show you in an app, this is just a front-end React 99, it's blocked. Why? There's a time interval before you can send another request. Now it depends on you. But here I think I sent, okay, 12 sec remaining. It's just a 60 seconds that I configured there. So I'm expecting after 60 seconds, the outage happened in AWS, already fixed, which is it's too fast still. should be like 30 minutes maybe. But here, 12 seconds remaining, already passed. Maybe now I can send requests. Yes, I can send requests because the circuit breaker is now closed. Meaning closed, it will start accepting flow of requests. So, yes. Any questions here?
Yeah, we actually have quite a few. So, is the presentation finished? If you're good, then we can. You can take a moment to relax. So you're quite rushing. We can sit down, go over the questions. Not too many, but there's some good ones.
Yeah. Okay. So I think I need to just finish these slides, then I can take some questions.
Yes.
Is that cool?
That's perfect.
Okay. So stop mirroring. Okay, so that's for the demo. Other usage of or scenarios of retry policy would be reading, writing to file system, using databases, reading, writing to message queue, or spawning a pipeline of connected programs via intermediate shell known as shelling out. So to summarize this, retry policy, again, is just a request retried after short wait in an error response is received. Circuit breaker policy gives the target a service break, after a repeated number of failures. Resiliency, again, is about recovering from a failure, and then there are two types again, the infrastructure-based like API management services, or code-based, which is you've written or from third-party libraries. Yeah, I can now take some questions on.
Well, if the slides are on, then let's say thank you.
So to answer that question was if I can use these decorators in other function, right? Yeah. So you can, depending on the function you're building, but most of the time you can use it in asynchronous calls or asynchronous functions that you're building. Like I said, in the end of the slide, you can use it in a file system as long as it's an asynchronous. You can use it in a database, and actually you can also write your own retry policy. It's just a function that wraps another function. This is just cleaner way of, and has a better maintainability because you're using a decorator, right? Rather than just your own function that has another function. And yeah, that's it. Basically, yeah, you can use it in anywhere you want. Mm-hmm.
All right, that's great. Great to hear. Next question here we have is, for the retrying logic, do you also allow or have pre-built this retrying jitter or exponential backoff?
So exponential backoff, I didn't have a sample there, but just to give the viewers or the attendants here the idea of exponential backoff, exponential backoff is you're setting an interval, and then the interval gets multiplied while you're getting, errors, or another error can multiply the interval of the waiting before another request will be sent, and then if you get another failure, it will wait for longer than the previous one. So that's the exponential backoff. It's built into that decorator. You can use it. You don't have to write your own exponential backup. Well, you can, but it's already there. There's already an interface for that where you can use it.
It's quite flexible for the logic of the retrying, which seems quite good. when designing and writing this, did you already know, or did you discover the need for the circuit breaker by actually DDoSing yourself? Or is it a known thing that you had to do beforehand?
So the question was if I already know that...
Yeah, when designing it for the circuit breaker, this is something you anticipated, or more just discover going, oh crap, I'm actually DDoSing myself?
Oh, that's a good question. Well, if you're studying, if you're learning retry policy, you'll also end up reading circuit breaker, and they always go together, by the way. So it's not just you're gonna learn retry policy, you'll always, or most likely, read some stuff, in the middle of what you're reading, that you have to have this circuit breaker, because it makes sense that you have to have this perimeter or protection in your APIs. Otherwise, you'll just be flooded by this request, retrying and keep on retrying. Or you can add a rate limiter in your API. Doesn't have to be circuit breaker, but it's a pattern, and that's what others known for that. It's in circuit breaker, most of the time, it has a state in your application. It tracks that threshold, as you notice, right? There's a 2, you can set it to 3, and then every fail is just going, the circuit breaker will just going to track it. There's 1 already, and then it can wait for 5 minutes, and there's another 1. So yeah, unlike the other one that you can do, which is rate limiter, there's no state in rate limiters, just,
yeah. All right, thank you. See, there's a decorator for a specific view or endpoint, but is there already some sort of Django middleware that can be applied to the entire, the entire API? So every single view, every single endpoint has some sort of basic retry and circuit breaker applied, or do you have to explicitly say for every endpoint currently?
Well, I haven't encountered any generalized decorator that you can put and then it will just work in anything. What I can also recommend is, or just to warn you that this retry policy has to be in certain controllers or routers. You don't want to put that in your authentication URL or your authorization endpoint, and let that request keep on retrying because it's getting password error or something. So yeah.
Well, it's not going to succeed the second time. And is there a pattern to make the client not wait for a response, but instead try again later without keeping the connection alive?
Okay, so if there's a way for the client application, for example, mobile app or web app, to keep on retrying the request
without keeping the connection alive, so you should close the connection and then try again later. I'm guessing not, since this is only backend code here, yeah.
That's actually the normal. That's the normal functionality of a web client. It's just send a quick request. If there's an error, just return you this error, and then of course how you would build your UI. If you're going to show it, try again later. It's up to you. But you can see that that's a normal function, a result that the web application would do. I'm not sure if I got
I think
the question
because these
correct.
particular functions are mostly dealing with the backend, so it's really the client's decision to decide what to do with the eventual error or not. So it will be quite the typical case, or one possible case where client is requesting on the requested thing and the retries are just fighting each other until one of them decides to back off.
Okay, got it. Could be a web application behind the scene doing these retries. Yeah, you can use, for example, in JavaScript, there's a known library retry access retry. So if you're using a lot of Angular or React or Vue.js, there's a library that you can do this retry in the client application. It's a JavaScript library.
Yep. And that's all the questions except for this last one. For basically asking for the slides, since there's quite a lot of interesting diagrams there and references. So are you planning on publishing them somewhere, or do you already have them published, or can you share them with us and we can share them with the crowd?
Definitely, sorry. I will share the source code via GitHub.
Yes, that would be even better.
Yes. Where do you think I can
You
post
can
it?
just send it to one of us, and we can post
Okay,
it onto
yeah,
the,
sure,
the,
sure.
the
So
Python
I'll
channel.
just share the code so you can see. It's with React, with Django and the Fast API.
Yes. All right. So thank you very much for giving the talk.
Thank you also for listening, people here, and then also for people who's watching. Oh, thank you also for this
Yes.
gift.
You're welcome.